This video will give you a brief introduction to R and R Studio. The goals for the lecture are to familiarize you with the basic R Studio layout, show you how to create R scripts, how to install and load external packages, and how to do some basic exploratory data analysis. Okay, so R Studio basics. So R Studio is basically a software program that we're going to use to interact with R. And when you very first open it up, it looks something like this. Now, it's tough to tell, but there are actually 4 distinct panes here. So if I minimize this lower one, we can see the 2 that really matter most. So up at the top is the source, and this is where code goes. So I can write 2 plus 5. And because my cursor is over this line, when I press Control and Enter, that code is evaluated, and I can see the output of that bit of code in the console. So 2 plus 5 evaluates to 7. Now the source and the console are going to be the panes that we use far more than these other 2. So at the very beginning, I'd like you to do some rearrangement here in order to maximize your screen real estate. So what you're going to do is go up to Tools, Global Options, Pane Layout, and then select Console at the upper right and say Apply, and then minimize these 2 panes. Okay, we're really just going to use the source and the console for most of our work. Okay, so we've already executed our first R command. We wrote out 2 plus 5 in the source. With our cursor over that line, we pressed Control and Enter. We saw the evaluated output was 7. Okay, one of the most important notational pieces when you're programming is commenting your code. So the comment character in R is the hashtag. When you start a line with a hashtag, that basically tells R not to run that bit of code. So we can use the hashtag just to leave ourselves notes. To show you that, we're going to try creating and saving our very first R file. So if I go back to R Studio, I'm going to go up to File, New File, R Script, and then I'm going to start my script with a boilerplate that has some basic information about the file. So I've already written that out here. I'm just going to copy and paste it over. Now, you can notice that each of these lines start with a hashtag. So these are all just comments to myself. And here, I like to make sure that I include the file name, lab1 pre-lab notes, and a brief description of what that file is doing. So here, we're going to go through installation and loading of packages and some basic data browsing. Okay, first thing, before I do anything else, I want to save that file. So I'm going to say File, Save As, and I'm going to put this in this pfss temp directory. You can save your first script wherever you'd like. So I'll call this lab1 pre-lab notes. Okay, important to note that when I'm giving my file my title, I don't need to include the .r extension. That's going to be implied by my machine. Okay, now, after I've saved this file, you can see that up at the top I now have a tab that has this file name. It appears in black because there are no unsaved changes. But as soon as I make any change to my file, even just adding a space, this tab will turn red. So the color of the tab can inform you whether you've got saved changes or not. At any time, I can press Control and S to save, and you can see that the tab turns black again. Okay. Now, R is an open source software and benefits from work that R users have done all over the world and contributed. These packages, these external packages, are available to us for free, which is great. And to get access to those packages, we need to run the install.packages command with the name of whatever package we'd like to install. So one of the packages we'll use quite frequently is the tidyverse package. So the first time you're interested in accessing that package, you'll run the install.packages command. So I'm going to go back to my script and say install.packages tidyverse. Now, if I pressed Control and Enter, RStudio would go ahead and download this package onto my machine. I have already done this, so I'm not going to execute this command, but you should now. Important to note that installed packages only need to be run or installed a single time. After you install them, the way that you actually access them in a particular session is running the library command. So I'm going to go back to here. I'm going to delete this install.packages command and say library tidyverse. When I execute this, you can see that I get this feedback in the console. I now have access to all of the functions and data that come with the tidyverse. And as I said, we're going to use this extensively in our course. Okay, let's talk about exploring some data. R has many inbuilt data sets that are immediately accessible to you right when you download the program. So to see a list of some of these, you can use the data command. So if I execute that, I can see a big list of the data sets that are already available to me. Note as well that when I loaded the tidyverse library, many of the data sets from that library are now accessible to me as well. So we can look at data on all kinds of things, but to start, I think it'll be helpful to look at the mtcars data. So here, I'm going to write mtcars, and I'm going to execute this. Now when I do, I can see data show up in my console at the right. So this is a big data set. Now, you may have noticed the shape is a little bit weird. I have this kind of extra bit at the bottom. The data are formatting in that way just because I've sort of run out of space. So if I gave myself a little bit more room here and re-executed, now the data look basic and kind of rectangular again. So a few quick comments about data layouts. So the typical arrangement that we'll work with is a data frame. We'll talk more about data types soon. The setup for these data frames is that each observation gets its own row. So this first observation tells us some features of this car, the Mazda R4, and we can see from the headings here that we can observe features about the fuel efficiency, the number of cylinders, the weight, the number of gears, et cetera, et cetera. Now, as I said, each observation gets its own row in the data. Okay, so here, as I said, writing the name of a data set will print the entire data set. Now, frequently, we're going to be working with data sets that are too large to look at in one place. So we're going to want some tools for browsing these data sets. We covered this already. Typical data layout is that each observation gets its own row. Columns in the data are the measured features. Okay, so how do we browse data? The first really useful command here is a function called head. Now the head command takes one argument, meaning kind of one input bit of information, and the output that it gives us is the first several rows of data. So if I write head mtcars and execute it, I'm going to see the first 6 observations. So I'll show you that now. head MT cars. And I can see the beginning of my data here. Now, head is an example of a function. Functions basically just turn inputs, like the name of a data frame, into outputs. For example, the printed version of the beginning of that data. The vast majority of data analysis is just applying functions to make successive changes to inputs in order to generate meaningful, interpretable outputs. So functions are going to be quite useful to us in this course. All right, I'm going to show you a few more functions for browsing data. So the dim command will tell you the dimension of your data set, meaning the number of rows and columns. So if I ask for dim of MT cars, I'm going to see 32 and 11 in my output. 32 is the number of rows, 11 is the number of columns. I do that here, dim MT cars, I see 32 and 11. Okay. At the beginning of the video, we loaded the tidyverse library. Now the tidyverse is going to contain many commands, many functions that we'll use for exploring data. One common one is the filter command. So the filter command is useful for examining subsets of a data frame. So if I just want to look at a part of my data, one way of subsetting is I can specify some rule that I'd like satisfied in order to see an observation. So if someone asked me, for instance, about the cars that are particularly fuel efficient in this data, I might run a filter command in order to look specifically at the observations where the fuel efficiency, the miles per gallon, is over some threshold. So this is an example of the inclusion criterion that needs to be passed in order for data to be printed out for me. The other piece to note here is that the filter command is going to take two arguments. The first of which is the data set I'd like to work with, and the second is that inclusion criterion that needs to be passed. So when I do that, when I execute that, I'll show you in a minute, the output that I'm going to see is only the cars that pass the criterion. Only the cars whose MPG values are greater than 25. So you can see at the left that I'm only seeing output with the large MPG values. Let's try that out. Filter, MT cars, MPG greater than 25. And there's that output right there that we saw in the slides. Okay. Another command that's really useful is the arrange command. So the arrange command is going to allow us to sort the data set. Similar to the filter command, arrange takes two arguments. First, the data set we'd like to sort, so MT cars in our case. And then second, the variable that we would like to sort by. So if we ran arrange MT cars using this MPG variable, you can see that my output now is the same printed data set listed in order of MPG. Now, by default, the arrange command is going to sort in ascending order. But if you want descending order, you can just wrap DESC around the variable that you're using to sort. So let's show you that now by going back to R. So I'm going to say arrange MT cars MPG. Doing that first will sort in ascending order. If I ran arrange MT cars DESC MPG, that's going to show me the same data sorted in descending order instead. Okay, last piece here. So the commands that I've shown you so far, you can think of basically as print statements. And by that I mean, when we run those commands, we're not making any underlying change to the data set that we're working with. And we're also not creating any new objects. We're basically just printing things in the console. sometimes, especially when you're making successive changes to data, it's useful to store the changes that you're making. So to do that, we're going to use the equals sign in order to create new objects. So as an example, I could make a brand new object, which I'm calling efficient.cars, and I'm just setting equal to the output from this filter command. So if I execute this bit of code in our studio, so I'm going to say efficient.cars equals filter empty cars mpg greater than 25. If I execute this, you can see that the output doesn't look especially exciting. We just get in blue the input line of code that we sent in. Now, though, there's a new object called efficient.cars, and we can refer directly to this object. So I could ask, for instance, how many rows in the efficient.cars data? Here you can see that there are 6 rows in that data set. Alternatively, I could print it out by typing out efficient.cars and executing that, and I can see the full data set that passed this filtering criterion. Okay, so to summarize, this lecture has covered basic layouts in our studio, creation and saving of basic R scripts, installation and loading of external packages. Remember, you only need to install once. After that, you load a package using the library command. And then finally, we covered some basic exploratory commands for browsing data frames, namely the head command, the dim command, filter, and arrange. And then finally, we covered assignment and the assignment operator.